Okay, so this video I'm planning to show you how binary numbers can be multiplied and divided by 2, okay, only 2, very easily. So let's go into the video and see. Okay. How the main reason why we are taking the division by 2 is because 2 happens to be the base of binary number. So dividing by the base is the uh, solution, right? So because of that only it becomes easier. So because binary numbers base is 2, it's easy to multiply and divide by 2. Okay, we are not talking about any other number, we're just going to do with this multiplication and division by 2 and show you. Now this same theory, after I do, you can apply it on decimal number also and see. Only thing is in the decimal number, it should be multiplied and divided by 10 because the decimal number base is 10. Okay, so you can do a similar thing and do the division and multiplication in the decimal number. But let's do the binary number in this one and see. Okay, let's take an example. How do we are now first we are going to do multiply by 2 a particular number. So let's take the number 5. So if we take number 5 to multiply by 2, the answer should be 10, right? So let's see. So how do you write 5 in binary? 1 4, no zeros, no 2's and 1 1. So right, 4 1 and 1 1. So 4 and 1 is 5. So 101 is 5. The decimal number 5 is represented as 101 in binary. So this is the number 5. Okay, I have written it in decimal just to show you. Right. So now how do we multiply this by 2 to get the result as 10? So to multiply by 2, what you have to do is add a 0 to the end of this. So now we have 101, add a 0 to the end, like that. So when you add a 0, to actually understand what this amount is, we'll position it here, right? Now when it was 3-digit number, we wrote it here using 4 to 1 weight, right? Now it's a 4-digit number, so we have to start from here to make it 4 digits. This and it has to go into this. So let's position that, right? So let's put this one here under 8. This 0 we will put it under 4. This one we will put it under this. So basically 101 we have shifted onto the left side and brought it here to give room for the 0, right? So the 0 will come here. So if we add a 0, this is the value. So what is this value? This value is 1 8 and 1 2. So 8 and 2 is 10. See, so 101, which is 5, by adding a 0 to that, you are basically doing a multiplication. So that's why I said it's very easy. Just add a 0 to the end of the number, then that number is multiplied by 2. Okay. By the way, if you add 2 zeros, it will be multiplying by 4. If you add 3, it will be multiplying by 8. So like that you can go on. But let's just concentrate on the 2 now. Okay. So this is 10. Understood? So we took 5, by adding a 0, we have made the number 10. So that's a multiplication by 2. Let's look at another example. This time let's take 26 and see. So if we take 26 and multiply by 2, we should end up at 52, right? So let's see. How do you write 26? You can't put 32. We can have 116, 1 8. So 16 and 8 is 24. Another 2 needed, right? So no 0, 1 1 2. So this is basically 26, right? 16 and 8. 1. Okay, the zeros these numbers are not there, no, that's why we have put 0. So 116, 1 8 and 1 2. So 16 plus 8 is 24 plus 2 is 26. So this is how you write 26 in binary. Okay, 1 1 0 1 0. So now we want to multiply this by 2. So what do? Like I saw in the previous example, we have to add a 0 to the end. You just add a 0 to the end. Now when you put the 0, there is no weight here, so we have to actually basically shift this to the 32nd column, right? The weight column. So let's do that. This one will come here. This one will come here. This 0 will come here. This one will come here. This one 0 will come here. leaving room for the newly added 0 to come to the last digit. So now when we have this number, this is, let's add this and see, we have 132, 116 and 14, right? So 32 plus 16 will be 48, okay? 48 and 4 is 52. See, so we just multiply that. See, 26, by adding a 0 to that, it has become 52. So likewise, any number, if you add a 0 to the end of that, then that number is basically being multiplied by 2. So that is how we do multiplication, by adding a 0, right? So now let's see a slightly modified version of the multiplication in the next example, okay? So in this example, we are not only going to multiply by 2, but we are going to add 1 also by doing certain things, okay? So let's see that example. So we'll take the 5 itself. Now 5, if we multiply by 2, it becomes 10, but after that we are going to add 1. So the 10 should become 10 plus 1, 11. So let's see how that happens. So again we will represent 5, 1, 0, 1, 4 and 1 is 5. So this is binary 5, right? Now to make this multiply by 2, we can add a 0. But this time we are not only going to multiply by 2, but we are going to add 1 also. For that, you don't add a 0, instead you add a 1. So if you add 0 here, you are basically multiplying by 2. If you add 1 here, it is a multiplication by 2 plus 1. So let's see. So the new number is this. So let's shift it onto this column. This 1 comes here, this 0 comes here, this 1 comes here, okay, and this newly added 1 comes to the last digit. So now we have this value. The moment you add a 1, this is our new value. So this value means 1, 8, 1, 2 and 1, 1. So that is 8 plus 2 is 10, 10 plus 1 is 11. See? So 5, when you add a 0, it becomes 10, just multiplying by 2. When you put a 1, it's a multiplying by 2 plus adding 1. So when you multiply by 2, it will become 10 plus 1, 11. See? So that is how this multiplying by 2 when 1 happens. So let's do one more example in this. This time let's take 26. 26 means 116, 18, which is 24, plus no 4s, 1, 2 and 0. Okay, so this is basically 26. 116, 16 and 8, 24, 24 and 2, 26. So now we are going to multiply by 2 and add 1. If you are just multiplying by 2, you just put a 0, but this time we want to add 1 also. So we will put a 1 at the end. Right, so let's shift this onto the 32nd, this column, the column. Why am I shifting? Because if we just leave the 1 here, there is no weight for that. So actually this last number always should come in the 1th position. That's why we are shifting this new number so that it falls into proper placement, okay? So this 1 comes here, this 1 comes here, this 0 comes here, this 1 comes here, this 0 comes here, and the newly added 1 comes to the last position. So this is our new number. So let's see what this new number is. We have 132, 116 and 14 and 11. Okay. So 32 plus 16 is 48. 48 and 4 is 52. 52 and 1 is 53. So if you calculate this and see, this is the binary value of 53. So 26 multiplied by 2 is 52, 52 plus 1 is 53. So by adding a 1 here, you are multiplying this number by 2 and also adding 1 to that. Okay, so you can take any number and do this and see. If you put 0 to the end, it's just a multiplying by 2. If you put 1 to the end, it's a multiplying by 2 plus 1. Okay, right. So let's now go to the